Hi everyone, my name is Lydia, and this is what I wish they taught me about econometrics and introduction. To continue on this little mini arc on dummy variables, now we're going to look into dummy variables in log models. This video is going to be entirely concentrated on the intuition, and we'll have other videos that go further into the actual mathematical derivations and proper uses of this particular kind of model. So we are going to concentrate on a model that looks like ln of y being equal to beta 0 plus beta 1 d plus an error term. We're going to stick to our usual example used so far. We're going to have the dummy equals to 1 when you are employed and the dummy equal to 0 when you are unemployed. ln y is going to be basically your ln of wages, ln of salaries, whatever y variable you want to use. So now let's see what will the coefficient on this dummy in this case represent, because now we went from a simple y into ln of y. Let's do the same exact work that we did when we showed the interpretations of the dummy coefficient for the level model. So case 1, we're going to have d equals to 0, which means that when we do the estimation, we're going to have something like ln of y equals to beta 0 hat, because beta 1 is going to disappear when we substitute the d equals to 0. So this is, keep in mind, unemployed case. Then case 2 is going to be when d is equal to 1. So in this one, ln of y is going to be beta 0 hat plus beta 1 hat. Remember, as usual, the d here would have been a 1, and multiplying b by 1 is just b, so we'll keep it simple like this. If we subtract the two equations from one another, because remember we said that the beta 1 is the difference. So this is the case for the unemployed, and you had the intercept equally just to beta 0 hat. The case for the employed here, now the intercept is that beta 0 plus beta 1 hat. So if we subtract the two equations, and for us not to get tripped into it, I'm just going to call this ln y0 and this ln y1. So ln y0 hat minus ln y1 hat is literally just this beta 1 hat. So we knew it was the difference. Now, if we use the properties of the log function, that means that this is ln of the ratio. So, and actually I should have done here ln y minus ln y0 to get exactly beta 1 instead of minus beta 1. And then here I'm going to have the ratio y0 over y1 being equal to beta 1. If I keep working this out, it means that the ratio y1 over y0 is actually e to the power beta 1 hat, which overall would give us that y1 is equal to simply e to the power beta 1 hat times the y0. So the percentage difference between the two groups, normally you would have to also multiply by 100, but here first the percentage difference between the two groups will be epsilon e to the power beta 1 hat minus 1. And if you multiply by 100, you're going to get like the full percentage thing. So in a log model with a dummy variable, the coefficient represents the percentage change, the percentage difference between the two groups. And obviously the exact formula should be this one. However, we have learned that if beta 1 hat is small, we can also make the approximation and just take the beta 1 as is and multiply it by 100. So this is why in many papers, like you will see whenever you have like comparison of treatment versus control, they will say like the treatment increases wages by about 8% because your beta 1 was that 0.08. Okay, so the interpretation that we learned from the log level model, even though we now have a dummy variable, literally means nothing has changed. We still do that 100 times 100%. And it's just that instead of saying that when I increase my X by 1 unit, now you're saying simply when I go from one category to the other, or literally the difference between the two groups is now that 100 times beta 1. So in this case, you see the combination or how the interpretations and the intuitions that we had in the coefficient interpretation of the log level model intertwines with the dummy variable, and the combination gives us that now the coefficient in the dummy for the log level model is just the percentage change or difference between the two groups. Okay? So key takeaway in log models, and I'm going to be a little bit more specific actually in the log level models, but just keep in mind dummies can technically be just 0 and 1, so we will assume that's the unit level part of it. Dummy coefficients, measure percentage difference, between groups. In the next video, we'll prove this formula step by step and see exactly an actual example for an exercise. So stay tuned and I'll see you in the next video.